Welcome back to Boring Bitcoin. It's Dakota here. This is the show where we dig deep into the Bitcoin rabbit hole. Today, in this episode, we're going to be going over definitions about Bitcoin, things that are important to know, like what a address is or a UTXO, what these abbreviations for things are. So if you're a beginner, this is a great place to start. So Bitcoin is two things. Bitcoin is a network. It's a decentralized network of computers all around the world that are running Bitcoin Core software. And they call them nodes. These nodes, they make sure that no one is double spending coins. They make sure that everyone's following the consensus, that the proposed blocks are valid, that get added to the chain, and that there's no shady things going around. So there's like 15,000 nodes around, so that's the Bitcoin network. Whenever you see that, that's typically spelt with a capital B in Bitcoin. And then another part of it is, another definition for Bitcoin is the unit of account. Or the coin itself, and that's typically seen as a lowercase Bitcoin. So those are your Bitcoins that you have, lowercase, Bitcoin the network, capital B. So an address, a Bitcoin address, it's similar to a physical address or an email. It's the only information you need to pay someone with Bitcoin. It's just a string of letters and numbers, and there's different types of addresses. There's the old legacy addresses that are paid to public key hashes, and then there's the SegWit addresses that they start with like a BC1, and now you have some Taproot addresses. Most people are using SegWit addresses. Your client that you're using, your wallet, is typically going to have, SegWit. Sometimes it'll let you switch over to Legacy, but SegWit is what people use. It's cheaper to use SegWit on chain because SegWit removes the signature. So Bitcoin address, you use that to pay someone. Now, something to know about addresses, there's a thing called an XPub, which is an extended list of all of the addresses that your wallet controls. And every time that you use Bitcoin, that you receive Bitcoin, you should be using a fresh address. You have billions of addresses to use with this wallet that are derived from the XPub. And they call that the parent address, and then each parent address has children addresses or a child. So let's say you're buying Bitcoin from an exchange, and you want to put it in cold storage, which I would highly recommend. You get it off of the exchanges as soon as you can. There's usually a holding fee. They want to make sure, because it's in the legacy system, you're paying fiat. They want to make sure that you're not going to do a chargeback. So they have to wait for the transaction to clear, and then you're able to withdraw your Bitcoin and have it as an asset, be self-sovereign, hold it as a bearer asset. So we hear this term blockchain everywhere. It's all the craze, it's all the rage. So blockchain, it's important, but really the innovation is blockchain mixed with the Nakamoto consensus, which is proof of work. So the blockchain, it's a public record of Bitcoin transactions in chronological order. They're time-stamped, they're hashed with a Merkle tree that allows for, if anything in a block were to change, in a pass block, if any information were to change, the header of the hash would change if even one number changes. So that's what provides the immutability to Bitcoin. So the blockchain, it's distributed between all of the Bitcoin nodes, and it's used to verify the permanence of Bitcoin transactions, the immutability of them, and to prevent coins from being double spent. So next is the singular block inside of that chain, and these blocks are created roughly every 10 minutes, and the blocks will have this address, say Alice is paying Bob, and it'll be a string of numbers, how much Bitcoin they're sending, and the nodes have their own templates for making these blocks, and there's a bidding war that happens. If blocks are getting full, then the price will be higher because there's only a limited amount of space. Only about 5,000 or so transactions can fit into one of these blocks. So as blocks get fuller and fuller, the transactions get scaled up. So the fees inside of the block, the virtual bytes, the satoshis per virtual byte will change on how quickly you want to get into a block, and it's an incentive for miners to include you in a block if you're offering a higher transaction. So blocks are made about every 10 minutes, and a new block, it'll include the transactions that are in the mempool, and whichever miner finds the proof of work hash with the leading 0 bits for the difficulty at the time, that's the closest to what it's projecting, they get the block. And so there's a block reward. It comes from something called the Coinbase. This is how new coins are issued on Bitcoin. So the block reward, you win a block, you put in the proof of work, which means that you were guessing trillions and trillions of times per second to find out what this 0-bit hash is based upon the difficulty. And once you get to sign the block and share it with the network and broadcast it, and you add this chain to this chain, you're awarded whatever the current subsidy is. Right now it's 6.25 Bitcoin. That comes from the Coinbase, and it takes, I believe, 100 blocks before you're able to spend that Bitcoin. And the reason that the block reward is like that is that 2 people can win blocks at around the same time without knowing that they each won the block. And whichever block is added to the chain and has the most proof of work on it is the real block that was won. The other block that comes off of that is a side chain and gets no work done on it. They typically call that an orphaned block, and that block is now invalid. But that miner, the proof of worker, they never have a chance to even spend it because it takes 100 blocks out before they would be able to spend it. So confirmation means that a transaction has been processed by the network and is highly unlikely to be reversed. Transactions receive a confirmation when they are included in a block and for each subsequent block. Even a single confirmation can be secured for low-value transactions, although for larger amounts like $1,000, it makes sense to wait for 6 confirmations or more. Each confirmation exponentially decreases the risk of a reverse transaction. So there have been times, this is going back to those orphaned blocks, there has been times in the blockchain where a miner finds a block, they're rewarded with Bitcoin, and people keep on building on that block. But there will be a different block, a different blockchain that's going into the future, that even more work is being done on. So I believe the max that it has ever been reversed, that an orphan chain has gone off on the side, has been like 5 blocks. Well, that's a lot of transactions, so that get canceled, but they don't necessarily get canceled. If they'll go into the next definition, will be the mempool. So the mempool is a place where unconfirmed transactions sit, that they're waiting to be processed and included into a block. So in the mempool, you have, like right now, I think there's around 300,000 transactions that are unconfirmed, and most of those are very low bids, and you have people that really want their transaction to go through, and they will bid up the price. They'll say, I'm willing to pay this much in Bitcoin to have my transaction included in the next block. So the mempool is a space kind of in limbo where you've broadcast your transaction to the network, but you're waiting. And most nodes, or lightweight nodes, like a Bitcoin wallet on a phone or so, it'll let you select how much you want to, if you want it to be high priority, if you want it to be included in the next block for sure, or if it's medium priority, maybe it'll be 2 blocks out before it's included. And another thing, there's something called RFB, or RBF, excuse me. RBF is replace by fee, and that is a way to, you can say you really need a transaction to go through in the next 10 minutes, and all of a sudden there's all this stuff happening on the network. Then you're able to replace the fee that you are willing to pay miners to include your transaction. So it's a way of saying, like, yo, I need this to go through, so I'm going to pay, this many extra sats to make sure I'm top bidding and I'm going to be in the next transaction. Let's talk about double spending for a minute and what that means, and how Bitcoin prevents this. So if a malicious user tries to spend their Bitcoins to 2 different recipients at the same time, this is double spending. Bitcoin mining and the blockchain are there to create a consensus on the network about which of the 2 transactions will confirm and be considered valid. So if someone's trying to send these, one of the transactions will get spent, and that will be the one that's spent, and then they no longer have the Bitcoin, so the other transaction is considered invalid. As far as we know, there's never ever been a double spend on the Bitcoin network. Let's talk about hashing. So hashing is done, it means a couple of things when talking about Bitcoin. I'm reading most of these definitions from bitcoin.org. Others I'm kind of just free winging it. So the hash rate is the measuring unit of the processing power on the Bitcoin network. The Bitcoin network must make intensive mathematical operations for security purposes. When the network reached a hash of 10 terahash per second, it meant that it could make 10 trillion calculations per second. So the miners today that we have, they're making anywhere between like 10 to 20 trillion hashes per second. So or even more. I think there's miners that are doing 55. Maybe in this next round we have um, miners that can do 120 trillion hashes per second, and that's just one machine guessing 120 trillion times um, what the it's the 0 bit. This is the difficulty for Bitcoin. So it's a string of numbers that I believe is like 32 characters long, that you're trying to guess the hash of this. And whenever the difficulty adjustment happens, you are adding one more zero. So it starts off, it's a chain of zeros. And when Bitcoin started, it had to lead with a couple of zeros. Now we're probably up to this hash that you come up with. It needs to be like 20 zeros, and then the rest of it is this just whatever. It doesn't matter what the rest of it is. You just need the 0 bits. And you do this with nonces. You do it with hashing, where a hash is you put in any input. It can just be A, B, C, D. It can be Mary had a little lamb. It can be whatever amount of information, and you send that input, and it'll create an output. And it only works one way. And every time you do it, it'll make a hash that's like 64 characters long. The hashing algorithm that Bitcoin uses is SHA-256. It was developed by the NSA, I think, in like the 90s or so. So we'll talk a little bit more about mining. Bitcoin mining is the process of making computer hardware do mathematical calculations for the Bitcoin network to confirm transactions and increase security. As a reward for their services, Bitcoin miners can collect transaction fees for the transactions they confirm, along with newly created Bitcoins. Mining is a specialized and competitive market where the rewards are divided up according to how much calculation is done. Not all Bitcoin users do Bitcoin mining, and it is not an easy way to make money. So I believe to try and mine a block right now, it's going to cost you $100,000, $200,000. It depends on the amount of energy. If you're El Salvador and you're doing Bitcoin mining with a volcano, maybe it's a little bit easier because your energy costs are a lot lower. You also need the capital for the place to host the rigs. So you need a facility that has, a bathroom for the people that are working there. You need shelving units. You need the ASICs themselves. The ASICs are computers that are specialized for Bitcoin mining. Let's go into private keys. So a private key, it's a secret piece of data that proves that your right to spend the Bitcoins from a specific address or wallet through a cryptographic signature. Your private keys are stored in your computer if you use a software wallet, and they are stored on a remote server if you use a web wallet. Private keys must never be revealed, as they allow you to spend your Bitcoins for their respective wallet. So now we have something called seeds, mnemonic seed phrases, and these are your human readable versions of your Bitcoin private keys. And when people say not your keys, not your coins, not your Bitcoin, this is what they're referring to. Typically, whenever you go into a Bitcoin wallet and you go into settings, you can either look at your private keys, you'll write them down, you'll put them on steel or titanium, something like that. You could take a picture of them or put them on the internet. I would not recommend that. I would, at very minimum, put them on paper in a secure place, and best practice would be to put it into metal in case there's some crazy accident and your house floods or there's a fire, something like that. So Bitcoins, if they're yours, you have the private key. If they're not yours and they're on exchange, you don't have the private keys. Bitcoin wallet is loosely the equivalent of a physical wallet on the Bitcoin network. The wallet contains the private keys, which allows you to spend the Bitcoin and get it confirmed on the blockchain. Each Bitcoin wallet can show you the total balance of all the Bitcoin it controls, and it lets you pay a specific amount to a specific person, just like a normal wallet. So something that's important to know is UTXOs in Bitcoin. So UTXO stands for an unspent transactional output, and I don't hear this talked about enough on lightweight like mobile wallets. You'll just see all of your UTXOs in one pot, but that's not really how it works. If we were to use more advanced wallets, it'll show you every single time that you've received Bitcoin is its own UTXO. And something can happen, especially in high fee environments like we're in right now, where say it's $10 or $30 to send Bitcoin. You're just sending a single UTXO. You can use multiple UTXOs as an input to pay an output, and that does use more virtual bytes, which will increase the amount of fees that you pay. So something that you can do is send several smaller, say you have all these 50,000 Satoshi UTXOs, and you've been dollar cost averaging for a year, and every week you send a Bitcoin or some part of a Bitcoin to yourself, and you're holding that in a wallet. Whenever it's a lower fee environment, something that would be beneficial to you in the future, especially as fees become $100 or maybe even $1,000 in the future, is to consolidate these UTXOs by sending them all to yourself. So you use one of your Bitcoin addresses to send it to a fresh Bitcoin address, and then you'll just have one giant UTXO. Another thing with that is that, this may not be best practices, but something that I do is whenever I buy Bitcoin from an exchange and I dollar cost average, I wait until I have a large amount of Satoshis in the exchange before I withdraw. So I can go ahead and pre-consolidate my purchases of Bitcoin over time, and I'll put, say once I get to 1 million Satoshis or 5 million Satoshis, then I will withdraw it to cold storage. Okay, so this will be, we're going on a little long here. So I hoped I could have given you some information here about Bitcoin, some definitions, some things that maybe you didn't know. It is a very complex topic. There's a lot of videos about hype and price, but I do think it's understand that that the knowledge of understanding these key terminologies. There's things that I didn't get into here, but we'll get more into those in a later video. So thanks for joining me today for Boring Bitcoin, where we talk about the boring stuff of Bitcoin and we go deeper down into the rabbit hole. Please like, comment, subscribe, and share. Have a great day. Bye.